Welcome to this recorded session. Today we are going to talk about Semantic Kernel. My name is Thomas Martinsen. I am a Microsoft Regional Director and also a Director in Venture. And with me today, I have Henri, who is an AI partner solution architect at Microsoft.
That's right.
And has been that for quite a few years.
Yeah,
welcome.
Thank you. Thanks a lot, Thomas. You're right. Been quite a few years in this role, which also means that I got to go from kind of the traditional old style machine learning and natural language processing world to now getting to work with generative AI.
Yep.
That's been a lot of fun. I've been so lucky that I could, I've been working with GPT-3 and the early not early, but the early large language models from OpenAI. For a little more over 2 years now. So of course we had a little bit of an internal access. So that's been really good fun to be one of the first people here in Denmark to be able to do that.
Yeah, because you can say a lot have happened
for sure.
last year. It's not more than about a year ago that the public saw ChatGPT for the first time, and shortly after we also saw Azure OpenAI.
Yeah.
Come into play, and from what I see is that this has been really picked up by everybody. We see that, my parents are using ChatGPT, and more or less everybody knows what ChatGPT is, and we see that a lot of companies is also picking up on that and begin to use the benefits of Gen AI. We also see that it's not just on the no-code, low-code space, but it's definitely also on the pro-code, where we see custom enterprise solutions really can benefit from some of these new services that is available. And one of the services one of the frameworks that is available is Semantic Kernel. And that is what we're going to talk a bit about today.
Yeah.
And you know a lot about it. And over the last couple of months, you and I have talked a lot about the benefits of it and how we can use it and really put it into play. But can you try to put a few words on what is Semantic Kernel?
Yeah. Let's start with the very basic of, like, is it a product? Is it a framework? What is it, right? So maybe the first thing we need to highlight here is that it is, of course, an open source framework developed by Microsoft, maintained by Microsoft, but still an open source framework for software developers, right? So we also need to think about this as, who is this actually for, right? Because often when we talk about AI, we think of the data scientists, we think of the AI engineers, and while they, of course, can still get value out of Semantic Kernel, mostly I would say Semantic Kernel is for the developers.
Yep.
Just like how, now I should have thought of a good analogy beforehand, but just how other software frameworks are essentially removing the need to keep writing the same boilerplate code over and over again for every single project, for every single thing you're going to be doing. The same Semantic Kernel is doing for generative AI applications. There's going to be a lot of things that I will want to write for this project and the next project, and the guy in the next building will write the same thing for their project, right?
Yep.
And Semantic Kernel is just trying to take that and put it into an easy framework that is easy for developers to understand, easy to work with, works in ideally the language that they're already coding in, and takes away this, let's say, the more specific edges of, are we working with GPT-4 or 3, or are we doing it through Azure or through the OpenAI API, and all of these different considerations, to boil it down to, we're building an intelligent app. And that's kind of all we need to know.
Yeah, so one way of doing things.
One way of doing things, kind of agnostic to the AI details, so to speak, that maybe an AI engineer would then actually work with.
Yep. Now you mentioned languages. So which languages is supported when we talk about Semantic Kernel?
Yeah, so Semantic Kernel is currently available for C#, .NET, for Python, and for Java as well. And not all of those languages are necessarily equally far in the development. You will usually get right now, most features in C# and Python, and they're slowly being ported to Java as well.
Yep. Okay. If you were to explain some good examples of when to use semantic kernel, what could that be?
Yeah, so one great example, I think, would be that if we want to build, of course, if we just build a simple chatbot, we can do that without. But as soon as we get into a scenario where maybe a user doesn't just want that one thing, maybe let's say we build, we're running an e-retailer, like a web shop. And we have a chatbot there, and customers can ask questions about our products. That's very simple. We know whenever customers enter our little chatbot, they will want to ask questions about our product. So maybe with every single request, we're going to ask, our product database for relevant information. That's straightforward.
Yep.
We can do that quite easily. Where it gets more interesting now is if we want to open up let's say the scope or the range of what customers might get out of that chatbot. And maybe you could argue, are we then talking about a co-pilot? That's another thing, right? Are we talking about making our own co-pilot that needs to serve multiple purposes and multiple scopes? Maybe customers will ask, hey, so this order, when is it going to get here? Can I, what's my tracking number or something like that?
Yep.
That's not going to be found in the product database, right? That is information where suddenly we need our large language model to have other capabilities than the ones that we have already supplied it. But once we start adding multiple capabilities, how do we figure out what our large language model, our AI application actually does, right?
Yep.
We can, of course, just keep doing every single thing, right? And maybe if we give it 10 different capabilities, it'll start reaching out to 5 different databases and data sources. But that's terribly inefficient, and that's terribly inconvenient, very latent, or introduces a lot of latency, introduces a lot of cost. So if we want to figure out how do we essentially effectively determine what needs to be done, for example, that's one great use case for a semantic kernel.
Yeah.
Now, of course, there's many others.
So it works like an orchestration engine.
Yeah, exactly.
So which functions or services is it that we have inside semantic kernel that does all of this for us?
I think I would say 3 important aspects to semantic kernel that provide value. One of them is, of course, we've kind of mentioned it already, the ability to have some kind of function, right? Some kind of action that we can provide our co-pilot with, or our chatbot, or our AI app. I'm probably just going to say AI app to make sure I cover all my bases here. And in semantic kernel, these are called plugins.
Yep.
They used to be called skills, now they're being called plugins. The idea being that we can write a little piece of code, or actually also a prompt, and then have semantic kernel call that when it's appropriate, or when we decide we want that plugin called. So that's that one concept of plugins. This is how we make our AI apps do things rather than just being language back and forth.
Yep.
The other aspect is connectors. Sometimes those plugins, they are not just calling a language model with a particular prompt. Sometimes the plugin is calling a data source. If I want to connect, for example, to a document database I have in Azure AI Search, I would have to, in the worst case, write my own API integration code. I don't want to do that. Right? But it's such a common use case that, of course, the semantic kernel has native connectors to things like Azure AI Search, or if you want to, in the .NET version, for example, connect to the Microsoft Graph to get things on SharePoint and on OneDrive and those kind of use cases. You have a connector for that. You don't have to actually start developing that from scratch. That's the second one. And the third one then, which is kind of the tip of the pyramid, you could say, that's the planners. So I mentioned in our little web shop example, how does the model figure out when to do what? And that is where we can then utilize a planner. Of course, we can just call the plugins ourselves if we want to.
Yep.
If we as a developer want to kind of hard code the path a user can take in our application, we can absolutely do that. This would be very much akin to, the old school, maybe the phone bots, right? Press 1 to do this, and then we're doing that. We can do that. But if we want it to be a little more dynamic, a little more open, maybe we have users that could take paths that we have not foreseen. Maybe we have absolutely no idea what our users might want to do, and we just want to provide them the possibilities, and they can figure out what to do themselves, more or less. In that cases, we can use a planner. And the idea with planners is that we take these plugins that we have predefined, so we have predefined actions, but we can combine them dynamically. So maybe we could ask the semantic kernel to, out of these maybe 5 plugins, the user asked how to, for example, track the order. Semantic kernel, the planner could go in and say, okay, we have these 5 plugins. One of them is called the order status plugin. If the user asks about their order, maybe we'll ask the order status plugin to deliver that information.
Yep.
And now, without going in too much detail this early on, but of course, that can be one plugin that we're calling, but we can also take multiple steps. And this is where the planner gets really powerful, that we can say, okay, maybe step 1 is getting the user ID for that customer. And then we're passing that to another plugin that then gets their order, and then we're passing that maybe there's a shipping plugin that will then actually get the delivery time, and we can chain that. And we as developers don't have to hard code it. We can actually let the large language model reason over how to chain these plugins and how to pass parameters from one to the other in order to actually give our users the result that they asked for.
Yeah. So all we need to do is provide the bits and pieces for the connectors and the plugins, and then the planner will figure out how to and which plugins to use. How does it find out which plugins to use?
Yeah, so that's actually really interesting, because it is, to a lot of kind of us in the development community, this is quite counterintuitive. It's just like with everything else, large language models, it's just language, right? So we are, of course, not just giving the kernel the name of the function. Ideally, we are also giving along a little description of what this function can do and what it cannot do. So in my example here with the order delivery or the order status function, I would maybe describe that function and have a little line there in my code that says, this function is for getting the status of an order. It requires that you provide the customer ID so we can track the order, or maybe the order number or something like that. You describe the inputs, you describe the capabilities of the function. You can also say something like, with this function, we can find the status for orders. But if you need, for example, the shipping time, then call another function, right? So we can also set up limitations. And these things are not binding, right? There's no, we're not setting up an if-then statement or something that forces our model to go down some. It's not code. It's just natural language. But the large language model will take all of that into consideration if you want, without anthropomorphizing the model. But look at the descriptions of all of the plugins it has available, and then find out which ones of them are semantically closest to the task that I will actually need to perform.
Cool. Should you try to take a look at how some of this looks?
Absolutely, yeah. Let's do it. I have a little demo.
Cool.
Let's
here go like this.
That's perfect. Yes. So you should be able to, actually click the share button. There we go.
Here we go.
Yes. So now we are inside of my VS Code, and we've just jumped into the middle of this. So let's take a step back and see what we're actually working with here. We are looking at this example here. This is example code from the Azure team here at the AI Studio Copilot sample repository. And what they have in here is some really nice example code for getting started with copilots. And not just in one framework, but as you can see here on the left, actually in multiple frameworks. So if you're interested in trying out LangChain, for example, or PromptFlow, you can do that here, as well as working natively with the AI SDK. But we are, of course, looking at the semantic kernel implementation today. And what we have here, we can just quickly look at quickly look at the code, what's actually happening before we try it out. And there's a lot of code, so we're not going to go through it line by line, but there's a few things I want to highlight here. One of the things you'll see here is that, of course, we're initializing our kernel. Our kernel is kind of our logical container for where we register our plugins, where we keep all of our other things in it. And here, of course, we're using Azure OpenAI. We are getting the deployment of our model. In this case, I'm using GPT 3.5 just because it's nice and fast. And of course, we're getting our keys and everything. And then here we're setting up our plugins, and here we're actually adding them into our kernel. So this is the 0.4 version of Semantic Kernel. So we haven't switched to naming them plugins yet in this version. So here they're called skills, but essentially they're plugins. It's the same thing. And I'm already calling them plugins in my code. So here we're importing our skills. We're importing our plugins. We're making them available for the kernel to use. This is where we tell the kernel, hey, by the way, you have access to these functionalities, which also means theoretically we could have multiple kernels with multiple sets of functionalities, right? But we're getting ahead of ourselves. Now, the next thing we should point out here is we have a planner. In this case, we have something called a stepwise planner. And the idea here is that rather than making up a plan and then executing that plan and hoping it works, what we're going to do is we're taking one step at a time. And after every step, evaluating, did this get us in the right direction or not, right? Should we do something else instead, maybe? Should we maybe go a different direction, so on and so forth? There's pros and cons with this approach. Of course, here, we're taking a little more time because we're taking one step at a time, looking around, figuring out, okay, what's my next step? That's slower. But sometimes it's better. And it helps us recover from failure better, for example.
And getting a better result, maybe.
Hopefully, we're creating a plan, and then we're running the plan. That's pretty much all we're doing. And you can see this is actually the end of the file. So all we're doing is we're registering our plugins. Whenever something comes in, we're creating the kernel, giving it the plugins it needs. We're making a plan. We're running the plan. That's it. Right? Everything else, and you can see that up here, happens in the plugin directory. We have 3 plugins here: a chat plugin, a customer support plugin, and a delivery status plugin. And I'm going to show you the delivery status plugin because this is the one I wrote. It's very short, but which makes it great to explain it. We have a class called delivery status, and then here it has one function, and this function is called get delivery status. This is a very simple plugin. It'll just tell you your shipment will arrive in 2 days. It's a demo app. And if you ask tomorrow, it'll still be 2 days. But what's interesting here is this thing that we talked about just before, about how do we let the model know what this does. This is actually up here where we provide a description. And this description, it looks a lot like developer documentation, but it's actually not for human eyes. It's for the model. Because we're describing both the function itself, but we're also describing here the input. What does this function need to operate? Good. So if we run this now, I'll show you a little example. And ideally, hold on, I might still have. Perfect. So I have a question here. So we're running. There is a run script that essentially just redirects this to the right implementation, because we have, of course, other implementations in Semantic Kernel. We're running it with Semantic Kernel, and then here we provide a question. In this case, I asked, when will my order arrive? And I misspelled it, but that's okay. Luckily, large language models are very forgiving. And we can see now what's happening here. This is not very pretty. I got logging turned on, so I get to see all the dirty details here, what's happening. But that sometimes means that things aren't so pretty. But what we can see here is we can see the thought process of the model, and we can see exactly which prompts we're actually sending to it. You can see, for example, here. Hold on, this is the example here that's being provided in the top. But further down, hold on. I just gotta find the right place. You can see, hold on. Just need to find the right spot. It's very messy here. It's sometimes difficult to find because half of the prompt is, of course, an example that looks exactly like
the one
what I'm looking for. Okay, so here you can see we can see this this thought process here. We can see this is the example we provide. So we say, once I've gathered the necessary observations, come to a final conclusion. And eventually here it'll say, you see, end of thought process. And then it says, let's break down the problem step by step. And this is a very common way of prompting, of course. And you can see here, it performs an action. So this is something the planner has determined. And it says, let's call the delivery status get delivery status function, which is, of course, in our plugin.
Yeah, so it calls the delivery status plugin and the function get delivery status.
Exactly right.
The plugin. Yeah.
Yes. We could have multiple functions in one plugin just to organize them. But in this case, we
just give them a description, each one of them.
Precisely. Yeah. And we're calling it here. It says action variables. There's an input of 1. And if you have had keen eyes, you could actually see that in our message here, in our prompt, we have this piece here. The customer ID is 1. So in this case, for the demo, we're hard coding the customer ID, but that's why it's passing 1 here to this function, and then it comes back with exactly this here. Based on the information provided, your package will arrive in 2 days, which is exactly what we had put into our function. Now, I want to share another example because we can make this more complicated. I'm hoping that, so if I ask a question that's slightly more complicated, that doesn't just require one single call to a single function, like in this example, I could ask something like, how do I set up the tent that I just ordered? So let's say in this case here, we have actually not just the delivery status plugin, but we also have this customer support plugin. And that allows us to get the past orders and also ask about products. So here we actually have 2 functions, and we need them both to answer this question. So, and this allows us to actually quite neatly also look at the thought process. So here you can see thought. To provide accurate instructions on setting up the tent, we need to know which specific tent was ordered. Right? That's already correct. We like that. We can ask the customer for more information about the tent. Okay, this is a great example of where the model actually didn't do this correctly. What it should say, of course, is it should say something along the lines of, we know the customer ID already, or we can use get past orders to actually get the orders that and find out which one was ordered most recently. That's usually how it works. Great example of sometimes you don't always get what you're looking for. The outcome we get here in the end is unsatisfactory. The item number of the tent you just ordered is 1. Well, that's not very helpful. Let's run this again and see if we get a better result this time. Things are happening.
Here we go.
Oh, perfect. Okay, so now we got the result here. Again, to set up this particular tent, follow these steps, and then it gives us the steps. Great, but it's more interesting to actually see how did it come to this answer. And we can see if we look very closely and find the right place here in this. So it's still saying this. This is hard to read, but essentially what we can see here, it is getting the past orders. This is a list of all of the different orders that were ordered, when they were ordered, what was ordered, how much was paid for it. So it is calling the the get past orders function.
Yep.
And then obviously it calls the get more information about this product function to actually find to
How to set up the tenant.
Yeah, exactly.
Nice. Really good. And this is one way of using a stepwise planner, but there's also other types of planners.
Absolutely, yeah.
What could that be?
So another type of planner would be one where, like the sequential plan, where we want to generate the whole plan at once.
Yeah.
The nice thing about that is that we can then present the plan to a user and have them say, this sounds good, run the plan before we do anything. Here, of course, as you've seen, we are just watching, right? We are just looking at the lines showing up on the screen and hoping that things are working out and maybe rerunning it if it doesn't.
Yeah.
There is going to be a lot of cases, especially when we talk about building copilots that interact directly with users, where we would want the plan to be transparent and visible before we do anything.
Yep.
So in that case, something like a sequential planner makes a lot of sense rather than having it be, step by step, like the stepwise planner. Yeah.
Yep. So if we maybe should talk a little bit about the plugins. So you can say, right now you made a really simple plugin, and there's also already a lot of plugins available in marketplaces. For example, on OpenAI's marketplace. But you can also write like a library of your own plugins, right? That you then can use in different semantic kernels.
Yeah.
So you would be able to write a plugin, publish it could be like an Azure function in your Azure tenant, and then actually just reference it here. So you can say this very plugin can be used in multiple different semantic kernels and in situations, meaning that all of a sudden you can really reuse the code that the different business units is providing.
100%. And if we just since I'm still sharing my screen here, we might as well have a quick look here. The code of, for example, this customer support plugin. This is really, this is standard Python. Aside from the little decorators here that name the functions, I could write anything in. So you're absolutely right. I could have this be an Azure function, make it available through, not just the semantic kernel, but we've seen, for example, a lot of people also using the Copilot Studio if they're doing Copilot from Microsoft 365, or they want to call it from a Power Automate flow. They want to call it from, whatever kind of interface that's not kind of a semantic kernel based interface. Of course, you can do that too. Yeah.
Yeah. So all of a sudden, you can say that if you write your logic as plugins along the way, at least, then you can, even though you're not using semantic kernel, or if you're using semantic kernel, or if you're using or making something available in the public ChatGPT, you can reuse those plugins.
Absolutely. Yeah. Absolutely.
Cool. Really nice. Let's talk about where semantic kernel doesn't fit in.
Yes. Good.
So let me just stop the sharing here.
Good. Then we're back to our faces only.
Yes. So right now, this makes really good sense to use, and there are some clear uptakes on this. But how about some downsides?
Yeah. So of course, as you've seen, for example, with the planners, these plans are not generated out of thin air. There's, of course, something generating these plans, and that's always, or in our case, with these kind of planners, that's actually a large language model too. So it's not just the large language model responding to our request in the very end, but it's also a large language model that determines which function does it make sense to call next, for example.
Yep.
So, and whenever we're calling large language models, we have to consider factors of latency, and we have to consider factors of cost as well. In these cases here, we're of course utilizing a lot of tokens just to send, here's all the functions, here's all the context, and then sending that to the large language model and then receiving the plans back.
Yep.
So that's something we need to consider as well.
Yeah. Yeah, and we definitely need to take the performance into consideration as well. I know that in some of the recent updates that they have looked a lot into the performance, so really to speed that up.
Yeah.
So if we say, okay, when should we look into semantic kernel versus just using a normal completion client, for example? When to use what?
Yeah, so there are a lot of places where it makes sense to start just basic. If you know you are going to want to do this one thing and it's not going to grow, for example, to encompass other features, you might as well stick with a completion client.
Yep.
If I want to do my retail Q&A and all I want to do is to allow people to ask questions about the information I have on my website, easy case, right? If that's all that I need to know, all that I need to do, I can do that directly with the completion client. But once I want to either already from the start have multiple plugins, multiple capabilities, or I want to kind of leave the opportunity for me to then easily add on multiple plugins later, then it can make sense to start with semantic kernel. Because it's important to highlight, now I talked about the downsides of latency and cost when we implement planners, but we don't have to use planners, right? Of course, we can just use semantic kernel for what it is, an engine to organize our development, to split our functions into plugins. Right? That in itself has no cost and very minimal latency overhead. So from that perspective, that's something we can always do, and then we can choose whether we want to use planners later.
Yeah. Yeah, so the planners is an opt-in.
Yeah, totally. They're a feature, right? And we can choose to use a feature or we cannot. Yeah.
Really nice.
It's a little bit like it's a little bit like you can get a car that's self-driving, right? But you can still drive it yourself if you want to.
Yeah.
Right? You can decide to flip the self-driving switch on and then it drives. But if you want to take control, you can absolutely do that. It's a feature, but you don't have to use it.
Okay, cool. So what is the future for semantic kernel?
Yeah, so right now we are kind of at a very interesting time of semantic kernel. Semantic kernel is moving from its kind of like pre-release to its proper V1 release, and that's going to be interesting. It's going to be introducing a number of changes, a lot of them which will be breaking your code. If you're working like me, for example, the code I've been showing you is running on the 0.4 release on Python. So that's going to break if I try to upgrade to version 1, but for good reason.
Yeah.
Of course, those changes are made to make semantic kernel more robust, to make it more aligned to what's been happening since semantic kernel development started more than half a year ago, much more than that actually. So a lot of things changed in the large language model world. Things like the availability of function calling, for example, right? In the OpenAI models, that wasn't the case. That didn't exist in the very beginning when semantic kernel had its planners. Those were not considering the opportunity for function calling since that didn't exist. And to some degree, they fulfill, of course, the same requirements. To some degree. Semantic kernel can go a little bit further, but now at least it's utilizing that capability rather than re-implementing kind of the underlying logic in the kernel. And instead utilizes what's coming out of the box with the GPT models. That's one thing. I've also mentioned, of course, renaming skills to plugins. This is just kind of, and you'll find that in a lot of places in the V1 release that a lot of the, let's say, terminology has been aligned to the greater industry terminology. We've seen, the generative AI industry is very young, it's very nascent.
Yeah.
So over time, we start converging on certain terms, like in this case, it's plugins for these little, function containers, you could call them, right?
Yep.
When semantic kernel started, they called them skills, and now we just need to rename them. And unfortunately, that's going to break a few things. Yeah.
Yeah, but as you say, I think it's a really good thing to see that semantic kernel is making a place for itself where it fits into not just some development processes, but actually fit into an ecosystem. And using standards, and it's open source, as you also started by saying. So I really think that it has a good future going ahead, and it is a good framework to use when building Gen AI based applications.
Maybe that's also a good thing to highlight. Not just Gen AI built on OpenAI GPT models anymore, right? So one of the new things with the V1 release, of course, is also that it's becoming agnostic towards what kind of large language model you're using. You might be running Llama, you might be running Mistral, any of these other large language models, and you might still want to. If you're a developer and you're just building this application, you might not even care, right? So you want to write the same code, no matter whether some AI engineer is putting a GPT-4 or a Llama 2 large language model in the AI backend, right? Exactly. That shouldn't have to be your concern. You should just write repeatable code, no matter what it's being used for. So that's something that we're also going to see with V1 that I'm quite excited about.
Nice, really good. Anything else we need to mention regarding Semantic Kernel?
I think we've covered a lot of interesting bits with Semantic Kernel. Maybe point people to the great resources, both in the Microsoft Learn documentation, but also the Semantic Kernel GitHub repo has a lot of really good stuff. Notebooks for getting started, sample applications, plus a lot of other repos out there, right, that have Semantic Kernel as a basis, like, for example, the repo I showed here in the very beginning. I think the best way to learn it is to just get hands-on and try it out.
And I can definitely also recommend the Discord.
Very good point. Yes, Semantic Kernel has a Discord.
It does. And I will definitely make sure to share all of these things and starters. So definitely. Thank you so much, Henri. It's been a true pleasure to get some insights and pick a bit on your brain regarding Semantic Kernel. So thank you so much.
Absolutely. Thank you so much, Thomas.
Okay.